Alright, hello everyone. Today we'll be talking about inertia and how that really relates to what we feel and experience in circular motion, which is what we've been talking about in this unit. So first let's take an example of driving a car around a curve. So right here we have the picture, this box is the car and the curve is the lines. So we know that as the car moves along this path, let's say the car gets to this point and they start traveling in this circular motion around some center point. Let's say if we were to trace out a full circle here, they're traveling in this kind of circular path. Let's say, well, this center, C for the center. We know from what we've talked about so far that they have a tangential velocity, so at this point their velocity is, again, to continue in a straight line, so just along that curve they're at right here. That'd be their velocity at each point. And we also know that they have a centripetal, so toward the center, net force. So that's the net force, along with, again here, always centripetal toward the center of the net force. And now, what we also know is that when you're in circular motion, since the net force is centripetal, the acceleration has to always point that same direction. So we can draw in our acceleration vectors in toward the center as well. So here, this is what we know about circular motion and the direction of the velocity, direction of the net force, direction of the acceleration. Now, let's imagine we are driving, again, a car, and this time there is, again, a curve in the road, and we'll follow some circular motion, but we have a driver and maybe a passenger in the car. Imagine you're the passenger and you're driving down the road with your friend, and your friend suddenly takes a sharp left turn. Maybe you're merging onto the highway or something, or a sharp right turn. What do you feel? In this case, if it's a sharp left turn, what is it that you are going to feel? Take a second to think about that. You probably said that if you're making a sharp turn to the left, you're going to feel pulled to the right. Your body might feel sort of a jerk toward the right direction. And while this is what it actually feels like, it doesn't mean that there's any actual force pulling you to the right. So if you suddenly make this turn to the right, you and your friend might both feel that pull outward toward the edge of the circle, in this case, to your right. But, again, this is what it feels like. It's not actually a force that's pulling you. If we refer back up to our diagram we had before, we know the only real force pulling us is going to be that net force inward. There is no force pulling us out of that circle. Rather, there's just the force making us accelerate in that path to follow that circular motion. And the reason we feel this pull away from the center, in this case toward the right as we're turning left, is because of our inertia. Our inertia makes it so that we don't change our motion easily. So in this picture, we are driving straight until we begin to turn. Once our car starts turning, our bodies are going to continue in a straight line until the force from friction of our seat or maybe the side of the wall of the car is going to push us inward to make us turn. Thus, we feel that pull toward the right. So as the car is moving, we have right here, following the circular path, the car starts here, here we are. We want to just continue along this straight path, but the car starts to turn. So we feel, again, that pull toward the right. And again, eventually, once we do have that net force toward the center of the seat or maybe the side of the door that we hit, then we will begin to move in that circular path. But until there's some force on us, the car will start moving in a circular path, and our inertia will have us continuing forward, feeling jerked away from the direction we're turning. In this case, feeling jerked to the right if we're turning left. Now, for another example, if we take this right here and we see that we start turning to the left, let's say that now we are turning to the left and we hit a really big patch of ice. Let's say that this whole thing, this is all just ice, super snowy day. What's going to happen here? You might be inclined to say, oh, you'll continue along turning along that circular path. Well, what's really going to happen is it'll be a bit different, because Once you hit this ice, you have a velocity that is, again, tangent to that curve, so just continuing in a straight line. And since if there's ice, there's no friction, we're going to say that your velocity is going to stay the same. There's no force, there's no friction to make you change your motion, no friction to make you accelerate. So rather than following the path of that curve, you are just going to continue in a straight line, again, tangent to where you were. Drawing this in, again, as our velocity, it's going to stay the same since there's no force to change it, no force to cause an acceleration in some different direction. Now we've gone over inertia and how that relates to circular motion and what we feel and experience. Try taking a look at the rest of the class kick, watch the YouTube videos, and answer the questions down below.